white tigers are lacking melanin. You know, you should call dibs in on that. So we don't get to cover animal physiology much, but I think that sounds like a great pack question. So yeah, like there's other like pigmentation in other animals. I think that's a really cool topic. So again, so we're in Hawaii, right? So a lot of people come here, especially if they come from like a place with not much sun, and they want to tan, right? So why do we tan? Like, what's the whole purpose? Just to change color? Well, the cool thing about what causes why we tan and what causes tan lines, it both involves something we just covered. So it covers melanin production. So how do we produce melanin, and why do we produce melanin? So what we can do with melanin is that so this is the big reason why we produce melanin. It's this big ball of gas in the center of our solar system that's throwing out radiation everywhere and also throwing it toward our Earth. Can you treat vitiligo at all? You know, maybe I should try to see what the latest updates are for that. I would have to look up on that. But if there are any treatments, it probably involves immunotherapy, but whether there is any available, I'm not sure about that. Maybe they could take immunosuppressants, but that's a little too powerful, and if you take something that lowers your immune system, that also lowers your defenses against diseases as well. So yeah, it's really tough to treat autoimmune diseases in general. So I'm not sure if there's something out for vitiligo yet, but I would have to go through the medical literature for that. Okay, back to why we produce melanin. So ultraviolet radiation. So if you've had, I don't know if this one is still allowed in Hawaii because we banned certain types of sunblocks and sunscreens that are harmful to our coral reefs. But if you look at a sunscreen, you might see this special letters, right? So broad spectrum UVA or UVB, or they might just say only UVB, but the UV part stands for ultraviolet. Now with the epidermis and dermis, again the epidermis, the more outer layer, the dermis right below the epidermis. So with UVA and UVB radiation is that UVA actually penetrates deeper past the epidermis. But the thing is that UVA compared to UVB actually has a little more energy, but actually stops short of the dermis. So it's pretty much absorbed by the epidermis. But what it's saying is that there's actually, just like we have a spectrum of colors from red to violet, ultraviolet is beyond violet. So it also has, we can't see it with our eyes, like Mr. Peanut probably can because he's a bird. But the thing is that UVA and UVB, these have different radiation, like what we call wavelengths and frequencies, and they have different energy as well. But what broad spectrum just means that it absorbs both UVA and UVB if you put sunscreen over here on your epidermis. Okay, so why is ultraviolet radiation important? Well, it involves this chemical right here, this molecule. This is DNA, a cartoon version, and what happens is that UV photons, so even though photons don't have mass, they carry energy. And this is like, we don't have to go too much into the physics, but photons have energy. This is why, even if you have infrared light, that's why if you go to a restaurant that has those food under that red light and keeping it warm, that's the infrared radiation. So photons carry energy, and energy can break chemical bonds. So if you have all that energy being carried by a photon of UV light hitting the chemical bonds in your DNA, what can that do? That can break these bonds or alter these bonds, so it causes mutations. So the key point here is that UV radiation damages chemical bonds, and this can damage the DNA in your cells. If that damages enough of your DNA and your cells accumulate enough of these mutations, that can lead to cancer. So why do we produce melanin? The cool thing about melanin is that it has, if you've taken any organic chemistry or biochemistry, so all these double bonds are really great for absorbing energy because they have more, so you might, if you've taken it, or actually, don't worry about this if you haven't had OChem, but the thing is that the structure of melanin makes it so that it actually absorbs light very well, and it can actually absorb the photons instead of these photons going on to damage your nuclear DNA. So it's like melanin takes the hit for DNA and all the other compounds and chemicals and molecules in your cells. So the cool thing is that melanin structure is very light absorbent and it's able to absorb these UV photons. So that's what the big purpose of melanin is that it protects your cells and protects your body against UV radiation. So what we have here is a melanocyte producing melanin, but the cool thing is that when melanocytes themselves are hit with UV radiation, what they do is actually increase the amount of melanin they make. So when they make more melanin, what happens? Well, that increases the concentration of melanin in a cell, but what does that do to your skin? If your melanocytes are making more melanin in response to UV radiation, that means your skin gets darker. So yeah, the tanning process is a natural response of your body in response to UV radiation. So that's why we get those cool why we get a tan. It's our body protecting ourselves against this UV radiation. So yep, that's why we tan, to absorb more of these UV rays. Now let's go to top hat once again. Next question. Ooh, throwback to chemistry, and hint, think of your macromolecules. So these are all the types of your biological macromolecules. So this molecule over here, 7-dehydrocholesterol. And hint, sterol or cholesterol. What type of molecule is cholesterol? Okay, let's see the responses. Most of you said lipid, and the majority is correct. It is a lipid because classic giveaway that it's a sterol, it's cholesterol. It has these 4 rings, those 3 hexagon and pentagons. So it is a lipid. Now, why am I bringing up this 7-dehydrocholesterol? So it might be like, oh my god, melanin is like, or not melanin, UV radiation is really bad, right? But is it always harmful? Well, it also involves this is why I bring up that 7-dehydrocholesterol. So it is a steroid, it is a lipid, but the cool thing is that UV light can actually break some of these chemical bonds. And when it breaks this chemical bond right here, and you don't have to know which specific bond, again, this is an organic chemistry class, but what happens is it forms this other compound called cholecalciferol, which is vitamin D3. So by breaking this ring, this is why you can still see some of the original structure of 7-dehydrocholesterol, but with vitamin D3, you notice that this is kind of a broken ring. So this is why UV light can actually be beneficial. It actually is an important way of your skin generating one of the vitamins you need for normal, healthy daily function. So what we have here is that, how is this related? Well, here we have the world, and again, not geography class, but here's the equator. And where does the sun travel? Well, the sun travels in which parts of the world get the most exposure to sun and direct sunlight? Well, again, the sun and the equator, this is the part that's in the middle of our axis, or actually our Earth's axis. And what we have here is that the sun, as they're closer to the equator, people living in these areas that are closer to the equator, they get more direct sunlight. But people who live closer toward the north and south poles, they get less direct sunlight. Again, not an Earth science class, but here's another cool image showing that kind of phenomenon. So again, this is why people living near here, and we're not exactly at the equator, but we're pretty close, definitely closer than the poles. So we get a lot of sunlight, and that's why a lot of people fly to our islands, or they like tanning here because they get more sunlight. And this also is related to something called the Fitzpatrick Scale. So people living who have genetic origins from geographic areas closer to the equator, they have darker skin tones in general. And why is that? Well, it deals with the level of sunlight, and the levels of sunlight also deals with the levels of UV radiation. So the Fitzpatrick scale is a general way. There's not, I mean, it kind of just categorizes based on not just like the appearance and how fair or how dark how much melanin you produce, but also like how easily you tan, and also how pigmented your skin is, and also how often you are get sunburn as well. So I think I'm naturally type 4. I tan with ease. That's probably the half Filipino. Like even though I've moved several clicks toward here, superficially, like I know if I spend more time in the sun, I'm going to get like back to olive skin again. But why is the scale pretty important? Well, the thing is that if you have more melanin, that absorbs more UV light. So if you have less melanin, that means more UV light gets to your skin, but it also increases the rate of making vitamin D. So this is the trade-off. If you have a darker skin and more melanin, that absorbs more UVB. So if you have less UV light coming toward your skin and there's deeper layers, people who produce more melanin, they have less vitamin D. And then but this is the thing, remember melanin is protective, right? So people who have fairer skin and burn easily and aren't able to produce melanin in response to UV light, they have increased rates of UV damage and risk of skin cancer because they don't produce as much melanin. And this is the benefit of having a darker skin tone and increased melanin production. You have more protection against UV rays and less risk of skin cancer. Now, does that mean zero risk of skin cancer? No, and actually there's a real cool movement like saying that skin cancers and people who have darker skin tones and produce more melanin, we should be looking at that, because this might be going undetected, because we think, oh yeah, they have a darker skin tone, maybe they're probably more protected against skin cancer. Well, you can still get skin cancer, just less of a chance than people who have fairer skin. Yep. Yeah, actually it's funny because like even my my dad is like, I don't know if he's type 1 or type 2. I mean, even though he's Okinawan, like if he doesn't tan, he burns. So he's probably like type 2. But yeah. Thanks to mom, I have type 4. Okay, so that's the trade-off. So it's not in terms of like UV protection and vitamin D production. So again, if you have a darker skin tone and you produce more melanin, you have more UV protection and less risk of skin cancer. But that just means like if you move to somewhere that's like that doesn't get a lot of the sun. So say someone has a really dark skin tone and they move to like Finland or somewhere like Alaska where sometimes they don't have any sunlight during the day. Well, this is where you might want to work with your doctor to sometimes for people who have darker skin tones and they move to a more northern or southern geographic area, they might get additional vitamin D boosters, because if they don't get enough sunlight, they might have a lack of vitamin D. But on the other side, we have like the fairer skin tones that don't produce as much melanin, so you have increased vitamin D, and this is another reason why we find people who have ancestry from the poles and the northern and southern areas, they tend to be fairer skinned, because if you have very little light, you want more UV radiation to increase your production of vitamin D as well. Okay, so that's what we have there.